about that. Welcome, everyone. Before we begin, can I just remind everyone if they can mute your microphone so we can be respectful to our presenters when they present and they're uninterrupted. And then after the session, when all our presenters have spoken, we're going to go ahead and open it up for Q&A. So feel free to unmute then and ask questions, or as always, put your questions in the chat box. We always appreciate that as well. Once again, welcome to another edition of our webinar, the Trees Around the Globe Student Research Campaign webinar. Today is going to be a very special one for us because we're going to be celebrating the kickoff of our Spring 2022 Tree Height and Land Cover Intensive Observation Period, which starts in 16 days, April 22nd through May 22nd. And I believe there's a saying, if you want someone to remember something, you have to repeat it at least 3 times. So consider this your first warning, if you will, or first mention of this spring campaign. So I just wanted to put this up there so you guys can all see. And we'll talk about the campaign in a minute. We'll talk about the partners as well. So let's go ahead and jump into the agenda. Wrong arrow. Of course, now my thing doesn't work. There we go. Okay, so this is the agenda. I'm going to leave it up for just a few minutes and go over it so you know what to expect for today's webinar. So we're going to start off with Brian and myself. We're going to talk about the introduction to the IOP. We'll go over the logistics as well and talk about the website. Good. Out of the way. There we go. And then after that, we're going to go and turn it over to Dorian, our very own Dorian Jenny from GPM. And she's going to be talking about how and why we measure precipitation from space, the impact of precipitation on land cover and trees. And then after that, we're going to turn it over to the European Phenology Campaign team, folks we always love working with, Lanka, Bara, Dana. And they're going to talk to us about the call for the European Phenology Campaign to participate in the tree height and land cover observations during this time. And then we have Kevin Chakowski, our own Bitmoji on hand from the Urban Heat Island Effect. And he's going to be talking to us about the importance of combining and aligning tree height, land cover, and surface temperature observations. And then we're going to have Peter Nelson, who's a part of our team as well. He's going to be talking about Landsat, 50 years worth of Landsat data and how we align that to looking at Earth change over time. And if I'm not mistaken, Landsat is the longest NASA lineage program that we have. You really can't beat 50 years worth of data. And then after that, we're going to have a very special guest. We're going to have Magda from the United Nations Environmental Program. And she's going to be talking about UNEP at 50 and how UNEP aligns with the GLOBE collaboration. And then after that, we're going to turn over to someone we don't get to see or hear enough of, and that's Alla. Alla, I apologize. I'm pretty sure I'm going to butcher your name, but it's Alla, and you can correct me after I'm done. Alla Wininska, I think. I'm pretty sure I'm wrong. And she's going to be talking to us about 50 years of UNEP, 25 years of GLOBE polling, and the decade of ecosystem restoration and how GLOBE is supporting this activity. And then after that, we're going to go ahead and turn over. I think I'll be moderating the Q&A. And then that's what I mentioned. Feel free, unmute, ask our presenters some questions. You can always use the chat box. So after they're presented, feel free to start asking questions. And presenters, once you're done, if you can look through the chat box and start answering any questions that we may have from our participants, that would be lovely, because we don't often have enough time to answer everyone's question. Let's see, next slide here. Okay, has anyone told you about the Spring 2022 Tree Height Land Cover IOP? Maybe, perhaps, almost? Well, let me go ahead and talk to you about the partners that are involved. And then I'm going to go and turn it over to Brian. He can tell you more about the IOP and what we plan on doing with that. So who is involved? First off, hopefully it's going to be you guys. Everyone in this room hopefully takes part and helps us make some measurements here during this period of time. It's about 16 days from now. So it includes a 4th year of the Trees Around the Globe Student Research Campaign. That's Brian, myself, Dorian, Peter, Chris. It also includes the 2022 European Phenology Spring Green Up campaign, 25th anniversary of GLOBE polling, and the 50th anniversary of the United Nations Environmental Program. So we have all these folks coming together. Hopefully we can grasp some great data and do some great collaborations with that data as well. The IOP will also be in parallel with 50th anniversary of NASA's Landsat Program. As I mentioned, the longest lineage program that we have at NASA in terms of getting consistent data. And then also with several of our other NASA satellites like ISAT-2, Jedi, and GPM. So hopefully we can do a really good job. Every year we've been a part of the tree campaign. We've always gotten a bit more and more data. And this is great to see because we see it, our program growing. So we hope that we can continue with that trend and get some more data during this IOP time. So with that, I'm going to go and turn over to Brian. Brian, I'm going to go ahead and drive for you. And you can go ahead next.
All right. Thank you, Peter, for the introduction. Welcome, everyone. And before I get scolded by our own Peter Nelson, I will say it's the NASA USGS Landsat mission. So I will add the USGS on there. All right. So as you know, with the GLOBE program, there are many complementary missions that, when we look at the data, like we look at, cloud data, we look at soil data, we look at, tree height data. There's lots of missions that we like to align to. And for this purpose, I grabbed 4 that are very important to not just the trees around the GLOBE Student Research Campaign, but looking at tree height and land cover in general. We have the Ice Cloud and Land Elevation Satellite 2, which is, it's in space right now for about 42 months. And we fired over 1 trillion laser shots at the planet to try to measure the height of objects on Earth, like ice and trees and buildings and landforms and things like that. We have the Jedi Instrument, which is a global ecosystems dynamic investigation. It's an instrument on board the International Space Station. And this measures tree canopy heights between 56 degrees north and 56 degrees south latitudes, and because that is the orbit of the International Space Station. And then we have the Landsat program, which Peter Nelson is going to talk in depth about later today during the webinar. The logo I have up here is Landsat 9. It's the most recently launched Landsat satellite. And this is the NASA USGS Landsat program, where, just amazing, as Peter mentioned, an amazing 50 years of data and looking at change over time. And then we have the Global Precipitation Measurement Mission, which, is a very vital part of the GLOBE program, because you're able to do some comparisons between the precipitation data that you measure, as well as look at the GPM data from space. And Dorian's going to be talking to you about that in a couple minutes. Next, please. So, basically why, who can participate in this? Everyone from students to educators to citizen scientists can participate in this IOP by, collecting tree height data and land cover observations, okay? Super important is that these observations aren't just for the sake of taking observations, right? They're for the sake of, doing better science, basically also helping to build a much more robust database for student researchers, professional researchers, to really understand and see just all this data coming in and looking how things are changing in local environments. And you can do that by simply looking at land cover and tree height observations. One thing that scientists like, and this is, professional scientists specifically, is that they look for something called data density. And that's a lot of data in a short amount of time in a particular location. And there's an example here that I put up here where we have some really a cool example of data density from the Netherlands, where they took tree heights. They took 274 tree height observations in a pretty small location, within the Netherlands, just in December of 2021. And the latitude and longitude that I popped there is kind of a boundary. It's a boundary of this whole area where it was taken. But as you can see, they had an internal campaign where they were getting the folks out there and the students out there to really take this data, take lots of data, in a short amount of time in a particular area. So this is a really cool example of this. And you may have seen this. We shared this as an example back on social media, on Twitter, especially the GLOBE program Twitter page back in December as well. So data density is one of those super important things that, that we're really looking at, because data density is extremely vital to scientists who want to compare the citizen science ground-based data to that of the space-based data, like from ICET-2 or the Jedi Instrument, or look at the land cover, from one of the Landsat missions. So yeah, so this is, anybody can participate in this. Even though this is part of our Trees Around the Globe student research campaign, we want everybody who is capable to go out and take these observations. Next. So here is where all this data is coming from right now. This is what's in the GLOBE database when we're talking about tree height and land cover observations. There's a lot out there, but we always can use more, because as you know, if we go and we zoom in further and further and further into this map, there's going to be a lot of open spaces. Okay. So that's one of our goals here, is to, try to fill in this map even a little bit more, during this month-long period of April 22nd to May 22nd. Next. So basically, how are we going to do this? You want to collect as much tree height, land cover, and we have precipitation data, which you'll understand why we're talking about that when you hear from Dorian right after me. But we want as much data as possible. We want, if you can, take multiple measurements in a small geographic area. So we like to have these, I like to call them this little pods of data all around. So we can take, if you want to take a tree height observation of the same tree every day of the month, hey, that's awesome. So we have that. So then if ICET-2 or Jedi or something would hit that tree, we're able to do a better comparison. Now, we understand here with the two images here that we have, the NASA Globe Observer trees tool and the land cover tool on your phone, okay? It's also possible to do it the traditional GLOBE way, where we, for instance, with land cover, we go out and, paste a pixel, and we go out and we look in all the different directions and observe what we're seeing, like we do on the app. But, map out, a certain area, if you've ever done the land cover protocol for GLOBE. And then tree height, if you've ever done it with a handheld clinometer, that's super, super fun to do. You just, have to do a tiny bit of math involved. The GLOBE program website shows you what to do. It's not too crazy. So, one of the things that we often suggest is, when you take a tree height observation with a NASA Globe Observer, also go out and take that same tree height with a clinometer and see if you can get a comparison. See, you can compare these and see how close you get between the two. And as you know, trees are land cover. So when you're out taking a tree height observation, take a land cover as well. If you start with land cover and you see there's trees in that land cover area you're looking at, also take a tree height if you can of as many trees in that area that you're observing with the land cover. And ultimately have fun taking these observations. Don't make it a chore. Have fun with it. It just happens if you're walking around, you're taking a walk, or you're on vacation somewhere, you're in your backyard and you're like, hey, I wonder how tall that tree is, or what's my land cover like here? I really haven't paid attention to it. This will really help you out. So have fun have fun doing this. Next. All right, so finally, this might be the last one, I'm not sure, but why tree height? There's a lot on here, but as you know, if we're talking about tree height's super important because it allows us to understand how healthy an ecosystem is. It also helps us understand how well an environment is suitable for growing trees, and scientists use tree height to help us understand Earth's carbon budget. It helps us understand the gain or loss of biomass, basically how much carbon is pulled in from Earth's atmosphere and then stored by trees, or potentially, sequestered by trees and then, released by trees. And land cover, and I know Peter will talk more about this, but land cover is the base data set for many areas of critical science. And you can see here, including everything from hazards to floods to fires and landslides, mapping wildlife habitat. Understanding what's around you is one of the most important parts of land cover. And basically seeing how that's changing over time. When we see how this land cover is changing, we can then try to answer questions as to why are these changing? Why are trees coming down? Why are trees starting to grow more here? Why is there more water here than there was before? There's lots of, the sky's the limit with these answers. So, this is one of the things that scientists really focus on. They want that data to answer lots of questions that they've come up with in their research. And next. All right, here's just, the websites that are available here. And quickly, Peter, if you could stop sharing, I'm going to share real fast, and I'm just going to pop into the website just so people can see what's basically on there. And then I will pass it over to Dorian in about 30 seconds or so.
And Brian, did they get that really cool badge for their page as well?
Yes. Yep. Yeah. So that's great. So yeah, you will get a digital badge. Sorry to mention that, but you will get a digital badge. I will send one out after the thing is over. So after basically May 22nd, you receive a digital badge. I will send that out to everyone who has participated, and you can pop that on your website. You can put that on your social media profile page or whatever. So feel free. And let me do this here. So on here, about the spring 2022 IOP, and I won't go through this all. It talks about what it's about, who the partners are, and then it goes through. There's links to the GLOBE program protocols if you want to do it traditionally with the tree height, land cover, and precipitation. That'll take you directly to the online protocols, and then links to the trees tool and the land cover tool on our GLOBE Observer page. Right now we're in this webinar, but let me see here. Oh, I have some down here too. Sorry, I'm scrolling around pretty quickly. But we also have some affiliated NASA missions. We have ISA2, Landsat Sign, GPM. I have to add the Jedi one there. But yeah, so so we have some really cool things. This is going to be part of the digital badges you get. We're playing around with it a little bit. It'll say participant on it, but it'll look something like this. This is the original badge was created from GIO, Global Implementation Office, but I went and we're adding some things to it to personalize it for this intensive observation period. So with that said, I'm going to stop sharing and I will pass it over to the one and only Dorian Janney, and she will talk to you about GPM. Take it away, Dorian.
Hey, you are so sweet. Well, thank you so much. So there's no way in 10 minutes that I could possibly do justice to this entire subject. So of course, what I did is I made a story map. So you will have access to this presentation and to all of these different resources. I'm not going to jump in and go through all the resources, excuse me, but what I am going to do is set the stage. So sometimes when we collect this data, we know it's often used by people who are writing papers, and that's all wonderful. But for some of us, we would like to maybe be involved and included and work toward a project that isn't necessarily a research paper that's being done, but that relates to something that matters to us and that we can be collaborating and sharing as this global community and getting a better understanding of our world, not just looking at our data, but collecting our data and then being able to compare and contrast it and also kind of share why it's important. So let me give you a little bit of the story here behind this story map. And then, like I say, you'll have all of this information available. So over here is one of the dearest things in my life, and that is my little granddaughter. That's a picture of her at 3 years old, standing by a plum tree in front of her house. So the question I'm posing with this effort is for all of us to consider and think about and learn a little bit about how might the trees in our own location change or be different by the year 2050? They might be the same, they might be different. It will depend, of course, on location, location, location. So in the context of this resource packet, this story map, you're going to learn some information about the differences and similarities between weather and climate. Super important thing to understand if you want to get a feel for knowing why we talk about climate change and how that could have an impact on the kinds of trees that are being grown. Then I go into, so that's that weather and climate section. Then I go into looking at climate change, looking at what we know about climate change, some really good videos that are related to helping explain and tell that story, with emphasis on understanding how precipitation may change as a result of climate change. And indeed, in some cases, how we already know that it's changed. As Brian said, I support the global measurement. So that is a satellite that is as large as a fire truck or a school bus. It launched from Japan because we're a joint mission with Japan. And it has been up measuring how much precipitation, both frozen and liquid, is falling from the clouds. So it flies above, and as it flies over, it's basically using radar and microwave data and using that data to remotely sense what kind of precipitation is in the clouds and how much is falling. Because it's able to get data from some other satellites, many of which are from other countries around the world, we're able to get these measurements for pretty much all over the world, with the exception of the extreme north and south pole, and update that data every 30 minutes. So as you might imagine, that is really helping us to better understand how the melting of ice caps and glaciers and some of our changing ocean and wind patterns are all kind of resulting in changes in how much precipitation is falling in pretty much every part of the world. So it's really very, very easy for you to get your precipitation data for the past 20 years and take a look at what the last 20 years of data have looked like, and maybe use that to better understand the water needs for trees in your location. And then also look and see if you note things like you have certain periods of time which are very, very dry in your area, or periods of time which are very, very wet, maybe big gaps between those. That's one of the really neat things when it comes to talking about growing trees. So as you know, it isn't just precipitation which impacts whether or not trees will grow. That temperature has a huge impact. So as I did a little research on this, I found some maps, some global maps and some US-centric maps, which are looking at this idea of hardiness zones for plants and for trees. So you can use that information to get a feel for, and you can do, of course, a deeper dive into understanding what these hardiness zones are. Basically, the zones are based on the average annual extreme minimum temperature, so how cold it gets during a 30-year period. And of course, the temperature is not the only aspect to helping trees grow. I did include a few resources where if you want to get in here and look for the hardiness zone, and these are US-centric, I'm afraid. For your location, you can go into that site. I am sure wherever you live in Europe or other places around the country have something similar where you could access that information. Then, of course, there's other environmental variables which determine which trees are sustainable in a certain location. So that's something you might want to think about considering. I noted here that I like to use an app on my phone called iNaturalist. I've used it when I've traveled in many countries, so I know it works in other locations. I like to use that to identify the type of tree that I'm looking at, if I don't already know. So what I'd like to invite you to consider are the ways in which we are anticipating our climate to change. And I've given some different resources which explain how we've made these climate models, we as in scientists at NASA, and how other agencies have kind of pulled this information together to come up with an idea of what we're thinking is going to happen as we look over the next 50, 100 years with climate in different areas. One of the things we found with the GPM mission, as we're trying to get a feel for, are some of these extreme flooding events or extreme droughts. Can we say that is definitely related to climate change? You know, yes or no? Can we take one event and make that correlation? There's been more evidence lately to suggest that we actually can, but that research is still being done. What we do know is based on these patterns we're seeing and how those patterns are changing, that there are going to be some locations where they are going to see a lot more precipitation. Where I live in Maryland is one of those areas. Over the last 10 years, we've gone from having an average of, and I'm sorry, it's going to be in inches, 4.5 inches per month. Throughout the year, we get a lot of precipitation. Well, not a lot compared to some places like during monsoons in India, say, but we evenly get about 4.5 inches of precipitation. 10 years ago, that was true. Now we're up to 5.5, 6 inches. So, it's only an extra 1.5 inches, but that, makes a difference. And if that's going to continue every 10 years for the next 30 years, that in addition to changing temperatures will make the kinds of trees that are sustainable in this area different. So I just thought that would be kind of a neat thing to think about. And so here's some resources so you can look at what the anticipated changes are in your area. There's also some really captivating research on, can planting more trees reduce some of the negative impacts of climate change? I included a NASA article, which you just click right there, and that will come up. And then a really fascinating study came up in the newspaper, the Washington Post paper, yesterday, looking at how tree rings from centuries in the past can reveal the warming planet's future. This data was done in Belgium, in various other countries in Europe, and in the United States. So when you get a chance, you might click on that article and take a look at how they're able to, and they don't have to cut the tree down. They now insert a little instrument that gets a little tree core, kind of a core sample like you would if you were out in the Arctic region and digging in the ice. So they get a core sample and it doesn't hurt the tree apparently, and they're able to use that to learn amazing things about the past, in some cases, centuries of what our climate was like, which gives us one more level of understanding for our future. But I'm going to finish up by inviting you to join, to tell your story, to join this project. To do that, the directions are here, and basically you'll do a tree height measurement. You'll pick one tree and you'll find out what kind of tree it is. So in my case, I picked a red maple that's in my front yard. I learned about what the water requirements are for red maples and the temperature requirements, just to give me that understanding so I can use that to try to decide and figure out, based on climate models, if this kind of tree will be still sustainable in, say, 30 years by 2030. So the directions are here. You'll do your tree height, then you'll do a land cover. So looking in the 4 directions, give us a feel for where your tree is located. If you like, and you'll give me a permission slip, and I included all that in the directions, you can send me a picture of you with your tree. And you can also give a little bit of information about, here's why I like this tree. Here's why I chose it. I'm going to just finish by showing you what that end product looks like and how you'll be added to this story. This is one of those things that I just love about our opportunities with the GLOBE program, is we're here from all over the world. So it gives us a really unique opportunity to be able to compare and contrast and share in these data from all over the place. I've been very lucky that a lot of people in Europe have submitted their data. We've also had Yash Raj, who's on this call, from India. He submitted his telling his tree story data. There's my tree story and one I did when I was out in Idaho. So I really like to get some more tree stories here and start adding you to our map. And you can go in here and look at some of these tree stories and get a feel for, in these different locations, how much precipitation do they normally get based on looking at that 20-year record. All right, so with that, I'm going to stop. Hopefully I've given you a taste of something that may taste like more. This is open to any and everyone. Your students might take a look at this and say, hey, we might do some research based on some of this collaborative data that's here. But It doesn't have to be a research thing. It can simply be you're coming in here and telling your tree story. So thank you very much for letting me jump in and say hi and invite you to do this.
Thank you so much, Dorian. That was wonderful.
My pleasure.
Let me now pass it over to Bara Semerakova from the European Phenology Campaign. Go ahead and take it away, Bara.
Thank you, Brian. Hi, everybody. It's my pleasure to be here with you today. And before I start sharing a screen, I just want to ask you, is here anybody who already observed the buds of the trees this spring? If yes, you can give me the reaction, the emoji of the heart, so that I can see if there is someone who already observed the buds of the trees this spring. Yeah, we can see someone coming in. Good, thank you. So basically, I'm here presenting on behalf of my colleague Lenka. We both represent the Europe and Euro-Asia GLOBE Program Region Coordination Office here in Prague, Czech Republic. And my brief presentation is basically a shout out to the teachers and students and scientists who are part of the European Phenology Campaign to join this initiative to also focus on tree height and the land cover observations during this IOP period, which will start in 2 weeks. So that's my main message. And I just call it looking at the trees from below, because that's what we do. Or that's what the teachers and students do. And I hope I'll be able to go further. Yeah. So this is what is already happening all around Europe. This week, next week, it depends on what latitude the countries are. So I'm pretty sure that in the south, Malta, Croatia, they already have leaves of the trees out. And perhaps up Estonia, they still don't have, but that's the beauty of it. And those are the activities that students do from March till May or June, even sometimes. And we prepared some more things that relate to this IOP. So what else actually you can do if you already observe the tree? You are measuring how the leaves are growing and what is the date of the bud burst. We encourage you also to add the tree height measurement of the same tree. This can be a nice exercise, nice learning activity. Also in mathematics, you can compare the measurement done by the clinometer and the measurement done by the app, the Globe Observer app. And the other thing, as Brian already introduced, the land cover module of the Globe Observer app is very useful for the phenologic observations as well. Because as we know, the trees that the schools observe, they are mostly close to the school. And the school usually is not in a wilderness, right? The school is in the town or in a village. So the settings of that tree is actually very much impacted by the land cover. If there is the paved area, or if it's in the park, if it's in a small, wood somewhere near the school. So you can also observe, like, if the dates of the bud burst, for example, next year, if it will be matching with some kind of, different type of land cover. You can take 2 trees that are in a different land cover situation, and you can observe that the same species of the tree would be the best. And yeah, so that's what I want to say. Please join us in this IOP as well, even if you already do the bud burst and the green up observations. And this is the QR code that will lead you to the a section of download materials where you will find the activities for students from the Phenology campaign. And we also added the activity of how tall is my tree there, the simplified, let's say, GLOBE protocol. So thank you for that. That's all. And if you have any questions, I'm here to answer them. Thank you.
Thank you, Bara, for the perspective from the European Phenology Campaign. And I have to say that you folks in the Czech Republic run an amazing campaign. So thank you for everything that you do and presenting today as well. So let me pass it over to Dr. Kevin Chakowski. He will talking about urban heat island effect and surface temperature. So all you, Kevin.
All right. Thanks, Brian. Well, let me see if I can do something here. All right. So I'm going to talk about urban heat island and also then how we can combine that with trees in the Phenology campaign. And this does come to us from GLOBE Mission Earth, the project that I manage that's funded by NASA. I guess we're probably pretty familiar with urban heat islands, how urban areas tend to be warmer than the rural areas around them because there's less vegetation, mainly. There's less moisture because the moisture either runs off or evaporates, and then the area can warm up. Our campaign, it's actually called a intensive observation period now by GLOBE. And we really focus on October, December, and March. But as part of this tree campaign, we would like you and encourage you to take observations of surface temperature, air temperature, and then clouds. And we have our instruments here. Now, the GLOBE Observer app can be used to enter surface temperature and air temperature through the atmosphere data entry at the top. And so if you want to do that, that'd be great. One way to do it is to have your students use a student account. And then when they go outside, the app will use the latitude and longitude of the phone as well as the time. And then the students basically just enter the data and they don't have to worry about the time and latitude and longitude. So it's a great improvement. And why do surface temperature? And I've talked about this before, but always good to remind us, the sun is the source of energy for the earth here. And then, so the energy comes through the atmosphere, warms the ground, the grass, the trees, the buildings. Some of that energy goes into evapotranspiration, that's water evaporating. Some goes into the heat we feel called sensible heat. And then some of the energy is emitted towards space, but greenhouse gases absorb some of that energy. And then there's our, as we increase greenhouse gases, that's our climate change. The infrared thermometer measures this emitted energy in the long wave radiation, long wave spectrum. So here's how to use your infrared thermometer. Point at the ground, push the button, let go of the button, then look at the value. And just a few tips. This is my youngest son, Timmy. Now he's over 6 foot tall and in college, but when I took these pictures of him, don't take the temperature of your shadows or your feet. It's a common problem that students do. Also, when you go to a site, we want you to take, well, at least 3 observations of a homogeneous area, but 9 would be best. So like of this grassy area, do 9 of the grass, and what not to do would be to take some observations of the grass and some of the softball field here, and then combine them into one observation. Those would be 2 separate observations in GLOBE. Now we set up a web page. Let me just show it to you, and I'll put this in the chat. Whoops, I picked the wrong one. All right, so we have this urban heat island page for students. Actually has a lot of some videos of how to take observations, how to collect your data, how to do a project. And then we have a link to a bunch of projects that are about urban heat island. We are focused on this year, artificial turf on soccer football fields. So we want to do that. And then here's my team. Some of you may recognize Femi from Nigeria. He's now a graduate student at the University of Toledo. And one thing, if you go to the projects, you'll notice there aren't any of trees in urban heat island. So that's what we want to try to encourage students to look at trees in urban heat island. So we'll just go back. Now I did just look at the IVSS pages, and Crestwood High School did one this year. So here's one, they're looking at surface temperature and tree coverage. And then they use the Aaron Terra rovers. That's what they have in the picture there. Use measures surface temperature and air temperature as you drive it around. So that's pretty cool. So if we want to do a project, we want you to take surface temperature and air temperature observations. You can do the app, as I mentioned. Do the tree heights with the app as well. And then maybe one thing to do would be in the sun and in the shade. So those would be two different observations, two different sites in the GLOBE database. And then you could map your trees through the land cover on the app as well. Just to show you where the data has been most taken throughout the world for surface temperature. I do want to point out there are some observations at 0 latitude and 0 longitude. So whoever's observations those are, you may want to fix that. And the students put in 0, 0. And then, just some data for surface temperature from, let's see, 2018 in this case. And then you can bring in MODIS data in the GLOBE database. So students can look at the satellite data for the same day. If I did something, I did this morning. I went to Google Earth Engine, and I think students can do this because there's a link and there's a database. You just click on this little box and Google Earth Engine opens up. Now you do have to log in or sign up for Google Earth Engine, say that you're an education entity, and then open up. And so let's look at some data. This is from the last summer, and you can see, like in Florida, Tampa, Miami, here's the urban heat island. The red is hotter, of course, than the yellows and greens. Gainesville here. So these are in Florida, different cities showing up just in this data. And students could see this. New Orleans, I think this, Charleston, South Carolina. Or maybe that's Savannah, no, that's Savannah, Georgia, sorry. All right. And then I just wanted to show a few other resources. My NASA data has a urban heat island story map. The story maps are a great thing. Dorian showed one. I actually went to it, and hopefully, when I looked at some of the stories, they're great. So you can do this urban heat island one. We also have a Google Classroom that can walk you through, or walk a teacher through getting GLOBE trained, and then giving some resources for urban heat island. So if you want to join that, please email me and we can get you into the Google Classroom that we developed. Another thing is NASA has an urban heat island badge that we developed. So you can go through the training there through the badges. And then here's our contact information. So thank you for coming and attending. And hopefully we'll get some more trees and urban heat island projects.
Thank you, Kevin. And what I did was on the website, our campaign, on the campaign page, there's the IOP website, which I just put the link to. I added the surface temperature protocol on there as well. So people know that that is part of it as well. So I added that as with the precipitation. So we have those 4 now. So thank you. All right. So once again, please feel free to add any questions you have in the chat. And as Peter Falcon mentioned earlier, that when all the speakers are done, we're going to then have some open Q&A where you can ask it live or keep in the chat, whatever. So without further ado, I will now pass it over to our great colleague, Peter Nelson from Oregon State University. He's on our Trees Around the Globe student research campaign and a GLOBE partner. And take it away, Peter.
Thanks, Brian. I really appreciate the opportunity to be here and talk about something that is really important, and that is the idea of generational science. We're not always in the classroom either, and a lot of us end up leaving the classroom, or we live in communities, and time keeps going by. And one of the things that I really appreciate about the GLOBE program is that it's been running since 1995. And land cover was the second protocol that was developed. This is also known as the site definition. And so whenever you start, before you do any GLOBE protocol, you should be thinking about what does this place look like today and what protocols can I do? You know, Dr. C there just mentioned making surface temperature measurements. But what's important to recognize is you are measuring land cover. He showed grass as one thing that you might be measuring, or impervious surface or pavement. Again, those are land cover pieces, and land cover is the foundation for so many research opportunities. And so, you know, this year we're actually celebrating 50 years of Earth observations from space. A lot of people have been measuring the land for a really long period of time before we put satellites up in space. And here on the screen, you can actually see what the GLOBE program has been doing since 1995. And I want to, like Brian highlighted, we've got a lot of blank spots on our map, actually. And so part of this intensive observation period is the opportunity to record Earth right now. And we put it into a database so that it will be there for today, and so we can make decisions and we can do our own research projects, or as Dorian was talking about, just investigate the world around us. But what is really powerful and really important about science and education is this database. So it's vital that we record what Earth is like right now so that we can make better decisions or informed decisions going into the future. So I just want to really highlight, if you find a blank spot on this map, fill it in. And the easiest way to do that is by using the GLOBE program's GLOBE Observer mobile app, and invite your community to be involved, because not only do we have these sort of observations of where they are, but we have that important piece of what is in those locations. And I think one thing that is really important to recognize is land cover changes. It's not static. It might be water one day, and then in 5 years, it might no longer be water because there was a drought or something like that. And then it might change back to water, or those trees are growing. And so it might be treed today, and it still might be treated in the future, but how tall those trees are, how big of an area that canopy takes up is changing. And so it can be really easy to think that our world is kind of static, or what I see isn't really important, but it is. And we want to make it easy for you to be involved and to record Earth right now. And that's it, you know, because it does complement the satellite measurements that are being made by NASA on many of the missions, or this joint international program, which is the Landsat program, foundational to our current understanding of the world around us. And the Landsat program has been going since 1972. And so this is our 50th anniversary of having these Earth observations from space. And you know, it's not one satellite, it is a series of satellites. And so as people have actually studied the environment, they've used this in the past. Students today are using that. And we anticipate students in the future are going to be using this to understand the world around them. And we really do need to tie it to what we see on the ground. I just want to highlight, you can actually see what Earth looks like right now from these satellites. There's this incredible tool that the US Geological Survey, who operates and maintains the database, the archive of all of these satellite records. So there's a lot of places to access these, but I wanted to just show kind of how incredible the land cover of this glacier area and snow-covered area can be when we look at it from above. Just mesmerizing in the shadows, in the way that the light reflects off of the surface of the Earth, depending on the land cover that is there. And here we're seeing this combination of water in all of its form, both in the sky, we can see some clouds, but also in liquid form here in the ocean, and then also in that solid form of the snow and ice that has been compacted together to form glaciers or snow-covered areas. Just really incredible. And I just want to highlight, I love this because you can travel along with the satellite and get that satellite perspective. Really, really exciting. And so, you know, take a look at one of these, see some areas from above, and then go explore them. Importantly, we have these maps that show us where land cover is, or what land cover is around the world. This is what scientists spend a lot of their time doing. This is what people who manage land need to understand the resources in that area, where the wildlife might be located. And as I wanted to really highlight with this, again, it's not static, it is changing. And so with certain satellites, we can only go back to 2015, like this one, which uses the European Space Agency's Sentinel satellite series. So that has only been up for 4 or 5 years now, 6 years. And so that depth of record is really shallow. And so again, that's one of these things that by working together, we can start to understand things like cause and effect because we have the observations. And if we don't have observations, sometimes we're making guesses, or we have to turn to satellite data to help us to understand that ground. So I wanted to highlight this particular My NASA Data lesson that introduces change over time. And this is created out of the lab that I work in at Oregon State University. And this really allows us to look at these changes over time. Importantly, Google has taken in all of that archive, and many of us can now look at these changes over time, at least as it looks in that natural color, human eye perspective. And so, you know, a lot of us, you can go anywhere in the world and zoom in, and there's a couple examples here that really kind of highlight some of the different stories that are happening. I'm going to just zoom in on this deforestation in one of our GLOBE countries in Madagascar. And you can see over time, things are happening, colors are changing. Now, is that because of phenology, tree phenology or grass phenology, those sort of changes, or are they longer term things that might be impacting where people are living or how they're working with that landscape? These are all questions that a satellite image from above provides. And we really do want that ground information to help us to calibrate or just to understand what is happening in this location. So I want to invite you to go and explore your location using a tool like this. Google's Earth Engine powers our ability to see NASA and USGS, US Geological Survey data that's been collected through this international program. And it's not just NASA that gets to make these. And this is, I think, one of these opportunities that go out, make some observations, but then make your own Landsat animation and share that out on social media. And so you can find the actual directions here on a NASA website that will walk you through this. And Brian, if we don't have this on our campaign page, let's make sure that it's there, because it's amazing when you start looking back in time and time traveling with this Landsat program, what they've been able to highlight, and share that with everybody. Add your photos to this so that it has some context. Here in the United States, we have a particular tool that I'm really fond of that actually allows us to see the areas where tree growth has been occurring. And we can see there are certain regions where we're getting a lot more green up, a lot more of those trees growing over time. And we know this only because of that generational science that Landsat, that satellite, those eyes in the sky have provided to us today. So we can actually look back because our parents or grandparents actually helped to pay for this satellite and have actually facilitated those measurements from space. Now, we don't have that same depth when we're looking at through the GLOBE program, but we really want that. And so, you know, when we look at the GLOBE database, again, we've got some really interesting patterns. And if we pull up or click on one of these locations, we can actually see, look, this is what this location looked like in 1995. This data is incredible. And there's really no other database out there that facilitates science and education in the way that the GLOBE program does. And when put together with this long-term satellite record consistently collected by NASA and the US Geological Survey, we can understand this. And so I just want to highlight that whenever you go in, look at this data count. And let's try to increase that density and help the students of today and the students of the future understand what is happening in our world around us. And finally, I want to mention, you know, sometimes there are events that are happening. And in particular, here is one that was submitted to us, not from the actual location, but there was a volcano that did erupt and started to change the landscape. And so we never know when these things are going to occur, where they're going to occur, and we want to record them. And we want to avoid data like this that gives us some information, but you know, it's slightly different than what we're after. But satellites are recording during the day and at night. And that really does help us to connect to some of what Dr. C was highlighting and our ability to look at that impervious surface over time, not just what it looks like today, but how it's been changing in the past. And then, as Dorian mentioned, how are things going to look in the future? All of that is tied up in making these observations and being part of a global community that is collecting data for science and education in a long-term fashion. So I'm just really excited that this year we are celebrating 50 years of the Landsat program, and be part of the science and education aspect of this, and join us in this intensive observation period. And Brian, I'll hand it back to you.
All right, thank you so much, Peter, and all those valuable resources. And you also see in there that we put a bunch of links in the chat. Karen Chakowski did as well. And in real time, I added the Make a Landsat GIF link. I added it to our website. So that's under the activity section on the Trees Campaign website. So thanks so much. All right, so now what I'm going to do is I'm going to pass it over to Magda Visiata, head of the World Environment Situation Room ESR unit. And we're talking about UNEP at 50 and some of the collaborations. So take it away, Magda.
Hello, everybody. You have to forgive me, but I am a Teams tribe, not necessarily a Zoom tribe. So there might be little glitches, and there you go. Can you see my screen?
Not yet.
Okay, let me, as I said, ooh. Okay. Okay, it seems like I cannot actually share my screen. Okay, let me see. I don't know why. As I said, I am a okay, there it is. Okay, maybe now it's gonna work. No. Can you see it now?
Yes, we do. Yep. If you just want to hit
okay,
the
perfect.
yep.
Oh my goodness,
Yep,
this
great.
is awesome. Thank you very much. So with my presentation, I'm going to change the resolution a little bit from down to earth, single tree or single location discussion to a more normative sort of a 10,000 feet view. But before I speak about UNEP as an active and moral supporter of the IOP, maybe perhaps I should introduce myself first. My name is Magda Biesiada, and at UNEP I oversee development and technical implementation of the World Environment Situation Room, about which I will speak a couple of sentences later on. Maybe it's important piece of information. I work and live in Nairobi, Kenya right now. So if we lose connection or I freeze on the screen, don't be alarmed. Our internet connectivity is not always perfect. In my presentation, I will focus on quickly introducing UNEP, then zooming down to biodiversity and nature action. I will talk about data at UNEP just very briefly, and then also briefly about collaboration with NASA GLOBE. So many people don't know actually about our organization, which is shocking for us as the members of UNEP. But UNEP stands for United Nations Environment Program. The program was established in 1972 in Stockholm by Maurice Strong, who is our first director. So already I am a second or third presenter that mentions a 50th anniversary this year, and this is also the case for UNEP. We are part of the UN family, where we are responsible for environmental issues and coordinating responses to the environmental issues. UNEP is in general responsible to provide leadership and deliver science and develop solutions on the environmental issues. For this decade, or the first part of the current decade, we are particularly focusing on climate change, nature and biodiversity loss, and pollution and waste. So zooming in further to nature and biodiversity loss, UNEP's promise or commitment to nature is to halt or and reverse loss of biodiversity, manage the nature within our development framework, but also conserve and restore nature. This commitment cannot be fulfilled or accomplished without measuring our progress. And this measuring of the progress happens through our data, within the scope of UNEP, we are operating through, our data work is focused through the World Environment Situation Room. And the World Environment Situation Room hosts different or deals with different types of data. These are satellite images. There's a lot of talk about this data already through today's presentations, but also data related to citizen science, civil society, or data collected by individuals or through interest groups. One of the sister data initiatives from the weather is also UN Biodiversity Lab, developed by WCMC in collaboration with UNDP and also UNEP. So these are two data related platforms that inscribe very well, I think, in the IOP initiative. WESR, or the World Environment Situation Room, is the data, information, and knowledge platform for UNEP, and then UN Biodiversity Lab provides decision makers with the best available spatial data to put nature at the center of sustainable development. I think that the fact that our organizations collaborate through the IOP or around the IOP gives us also a very good opportunity for UNEP to perhaps when the IOP is this year's IOP is completed, to host and disseminate the findings of and the data collection efforts of this year's IOP, and we would be very happy to reconvene after the period of observation and brainstorm on how we can better disseminate or how we can also through WESR disseminate the results of the observation period. So I've already started talking about the collaboration a little bit, but from the formal side, NASA GLOBE and UNEP collaboration started in April 2019. When I was preparing for this presentation, I looked into the agreement documents, and it actually happens that it was signed on April 5th. So yesterday there was a another anniversary of our collaboration, and the collaboration between NASA GLOBE and UNEP focuses on dissemination of mutual dissemination of information about scientific and educational activities, but also on dissemination of data and data products. Therefore, again, I think that whether through the framework of the NASA GLOBE and UNEP collaboration will be a very good place to help disseminate and inform global environmental community about the initiative of the IOP. And to finish my presentation, I'd like to leave you with a quote from Jane Goodall, who, and to maybe encourage the intensive observation period through the quote from Jane Goodall, who said that what you do makes a difference, and you have to decide what kind of difference you want to make. Thank you very much for your attention. It's a pleasure to participate in this event, and also to bring in the perspective, the more normative perspective of the United Nations Environment Program to this initiative. Thank you.
Thank you so much, Magda. That was great. Thank you for letting us know a lot more about the UNEP program. I've been trying to follow as best I can over the last couple of years, but your presentation really helped that out to fine tune what the program is. So thank you. And with that, I will pass it on to Ella. She will be our last speaker of the day before we go to questions. And sorry, we've gone a little over, but those of you who have been part of the Trees Around the Globe Student Research Campaign webinars know that we always have so much to talk about, and we always seem to go over. So we're not over too far now. But once again, I'll pass it over to Ella from UNEP Global Resource Information Database, GRID-Warsaw Centre, and the coordinator of GLOBE Poland. And as you know, GLOBE Poland is celebrating their 25th anniversary. So I will pass it over to Ella.
Thank you, Brian. Thank you so much. It's a great pleasure to be here today with you and talk about our activities. I'm so glad to have Magda here because we are directly connected, our organization and the UN family. Our organization, UNEP GRID-Warsaw Centre, was established more than 30 years ago, and we are a part of the UN family as well because we are the part of the science division, actually the same division which is linked with World Environment Situation Room. We were established as one of so-called GRID centers So our history is directly related with data and data collection. And we are supporting implementation of UNEP mission here in Poland, including also achievement of sustainable development goals. Those goals which were announced in 2015, we are doing our best to support their implementation. We are also the coordinator of GLOBE program here in Poland, and this year, as Brian mentioned, we are celebrating 25 years of our activities. So we are really proud because our schools, our students, they collected almost more than 3.5 million data. So I think it's a really huge input to the global database, and we are really proud of those activities. Right now, we have some teachers who used to be GLOBE students, and they love GLOBE so much that when they became teachers, they decided to implement this program at their school. So it's really amazing. As a part of UN family and UNEP program, we are also supporting the activities which are going on more global level. And I would like to mention one of those activities called UN Decade on Ecosystem Restoration. This decade has been announced last year, so it's there's still almost a decade ahead of us. And the aim of this decade, which was announced on the global level as the UN activities, so not only related to environment program, but the UN as a whole, it aims, the aim of this decade is to prevent health and reverse the degradation of ecosystems. We know that ecosystems are pretty important. They are important for our lives. We need earth, we need nature to live. And so the healthier our ecosystems are, the healthier the planet is. And all the activities which are going on, they are related to climate changes. They are related to, they can help to combat climate changes and also to help and the social challenges that we face. So what is ecosystem restoration? Here you have in the slide here you have a link to the video, short video, which I really recommend to see. But just to give a glance, ecosystem restoration means not only the recovery of ecosystems which are degraded or destroyed, but it's also linked with conserving the ecosystems which are in pretty good condition, and we would like to leave them in this good condition. Why it's so important? Because ecosystems provide so-called ecosystem services. For example, they provide water, food, clean air, and so on. So we really need nature. Without nature, we will not be able to live on our planet. That's why it's so important. In this decade on ecosystem, the focus is put on 8 types of different ecosystems. As you can see, they cover almost the whole Earth, from the mountains to the peatlands, from oceans to freshwaters, different ecosystems which are included, and all the activities which are going on in the decade, they are taking place in selected ecosystems. As you can see in the slide, there are also urban areas covered, because we also believe that urban areas are cities. Let's say cities, bigger, smaller, they are really important. They cover only about 2% of our planet, but more than half of our population lives in the cities. So that's why it's so important. And they also, when we look at the cities, they also should work as small ecosystems. So that's why they are included here. And as you can see, probably all of your GLOBE activities are taking place in one of those ecosystems. So even right now, even if you don't know about it, you work in different types of ecosystems, supporting their existence. Why the restoration is so important? As you can see, it's directly linked to different sustainable development goals. We have 17 sustainable development goals, and restoration of the ecosystem helps to achieve all of them. They are linked to different topics such as food security, water, education, mobility, everything. But ecosystems are so complex that they help to work with all of those SDGs. So how the GLOBE community can contribute to the ecosystem restoration task for the decade? Actually, you already do this through your normal GLOBE activities, because data collection can help on one hand to get to know environmental challenges of different ecosystems. So it can help to plan the restoration. On the other hand, further in the future, probably, it can help to monitor the restoration activities. So we can see if we're going in a good way, in a good direction. If not, maybe something should be changed. Maybe some new activities should be implemented. There's one important thing in GLOBE, which really helps to work with ecosystems and really helps to contribute to ecosystem restoration. These are so-called bundle protocols. You can find them on the GLOBE website. Here you see the path to do that. And when you look at those types of ecosystems in decade, you can see that some of the bundle protocols, they are directly linked to those ecosystems, and they can really help to get to know them better and observe them, collect the data, and also further in the future to monitor restoration activities. And even you can be included, and even you can join those activities. For example, for really simple things like when you are taking your measurements somewhere near the river, you can also clean the riverbank. If you are working in some area covered with trees, maybe you can plant some more trees to help the ecosystem to restore. Of course, taking all the local conditions into account. So that's why you need to observe trees, to observe the species and the weather conditions and so on, to make sure that you select appropriate trees to be planted, for example. And that's why those bundle protocols are so important. Looking, for example, at the agricultural protocol, you see that they are really complex. It means that you don't focus on one particular parameter only, but you are looking from broader perspective, because ecosystems are really complex. You need data on soil, on weather, on water, on human activity, and so on, to see the whole picture, the big picture of the specific ecosystem, and to be able to plan restoration activities in a good way. So this IOP is pretty important, because it can also help to get more information about specific ecosystems, particularly those which are covered with trees, but not only, because land cover gives us information about all other types of ecosystems and the conditions they are in right now. So as you see, you are already part of this decade, even if you didn't know about it. So also for this IOP, you can help to get more data. You can help to get to know some types of ecosystems better, and maybe it will also inspire you to take some ecosystem restoration activities in your local environment. Thank you so much.
Thank you very much. Thank you to all our presenters today. I know we ran a bit long. We do have a few questions for folks. And as we tend to always run long, but we always have such great presentations, it's kind of hard not to put anyone on a time limit. So we do have some comments and some questions in the chat box. But first, I'd like to do is go to Larissa because she wanted to say a few words about some of the presentators today. Go ahead, Larissa.
Yes, thank you very much, Peter. Thank you, Magda, and thank you to Ella for your wonderful presentations. Just for all of us to remind how beautiful GLOBE international community is as we work with 127 countries around the world. It's really, truly unique initiative. And I want to acknowledge Professor Mike Jabat, who is on the call from SUNY University. And also our thanks to Brian and Peter, and Dorian is disconnected, but also thanks to Dorian and to Peter. So for helping us with our teaching at the Global Diplomacy Fellowship in New York, at the United Nations Global Diplomacy Fellowship. Both Brian and Peter made tremendously successful presentations for our fellows, and our fellows are really connected to the GLOBE because they will be coming in the future science attaches around the world, and we want them to start those positions from really being involved with the GLOBE community. So again, big thank you to Magda in Kenya and Nairobi office, to Ella in Poland, and to all of you who are on this call. And again, big thanks to Brian, Peter, and Dorian, and Rusty, Professor Rusty Lowe, who is going to be a Fulbright Fellow in Brazil just next week. So many thanks again to all of you. It's really a fantastic GLOBE community. It's amazing work that we all do together. Thank you very much. Back to you, Peter.
Thank you very much, Larissa. One question that I've gotten multiple times in the chat box, but in private, is presentations. Will the presentations be available to people? People really enjoy them and will love to have copies of them if possible. So my question to our presenters, the ones that are still here, will these presentations be available, and can we share them with our audience?
Where do I upload the presentation?
We can probably contact you guys. Brian, I can contact you and grab those to put them on our website. So we'll get them for our audience. Just give us a little time and we'll post them up there and let you know when they're out.
Sure.
Question for Kevin, and thank you very much, Magda, for that. A question for Kevin. Can you name the IR-based temperature sensor, which is demonstrated in the picture that you showed while recording the surface temperature? Is it a regular IR-based thermometer?
All right, so again, the IR based in the picture, which picture?
So they want to know basically the IR-based temperature sensor that you used in one of the pictures. It's probably the one where your son is making measurements.
Okay, so
they want to know.
Tech City is the brand name that we tend to use. They're fairly inexpensive. I put in the chat. But is that it? Is that the?
Yep.
That's the answering the question then.
That is definitely it.
I sent it to Brian only. Sorry, hang on. He texted it, so I'll put it in.
Well, thank you.
There you go. Yep, now it's in the chat.
Excellent. Any last questions before I turn it back over to Brian? I'm looking in the chat box. I don't see any. There was a lot of information today, but great presentations. And as I mentioned, we'll get those presentations out to you once people share them with us. Okay, Brian, looks like there's no more questions in the chat box, so I'll go ahead and turn it back over to you.
Thanks, Peter. Let me go and thank you all for the amazing presentation today. And remember, the IOP officially begins on Earth Day, April 22nd, and runs through May 22nd. So please feel free to share this with everyone. Direct them to the website, have them go out and take some observations, lots of observations. So I'm going to end with, Peter mentioned earlier the digital badge. I'm going to show you what we have for this digital badge. Let me go ahead and share this. All right, this is, can you see that, Peter? Is that okay on your end? Peter Falcon?
Yes, you can.
Okay, cool. So this is a digital badge that will be sent out later on, after the IOP concludes, after May 22nd. But this is the one, like I said, this is the design was created through GIO, and we added to it. We added the partners who are part of this on the bottom, and we had to add Kevin's emoji / avatar, Bitmoji, whatever you want to call it, on the bottom. We love that. So, but this is the digital badge that, you know, everyone will be able to, you know, have for themselves, or, you know, potentially if you're registered in GLOBE, to put on your GLOBE page to identify that you are a participant who has taken observation data for tree during this spring, 2022 spring tree height and land cover IOP. So with that said, I just wanted to thank everyone for presenting and all the participants from around the world. It looks like we had participants from about, I think I counted it right, about 16 countries were here. So that's awesome. So thank you so much. And we apologize as always, but we kind of don't apologize because we always have so much information we want to talk about. But, you know, we do go over most of the time. So we are cognizant and we want to be respectful of your time. And we understand that if people need to drop off at any time, that's fine. We understand that. But with all these great presentations from around, literally from around the world today, you know, really understand that this is not just a singular IOP. This is a global one that we want everyone to take some observation. So thank you all so much. And until next time, I should also mention, I will send an email out to our listserv for the campaign, that once we have the recording from Zoom and then all the links, and after we get the, you know, the presentations from the presenters, we will then, I will send an email out with all this information. So thank you all so much.
Brian?
And until next time, yes.
Yeah, Brian, thank you for organizing this webinar. It's a great kickoff to the IOP. All of the presentations have just been great. A warm thank you to Magda for joining us today. And Magda, we look forward to getting together with you after the IOP to see how we can best work together to distribute the data. So thank you very much.
Thank you, Lynn. All right, thank you, everyone, and we'll see you all soon.
Take care, guys. Bye-bye.